Alright, so let's code our very first AI. It's not going to be an actual AI or useful AI, but it's definitely going to drive the concept of structured randomness home. So in the previous video, we talked about while loops. By the way, this is part of our series, AI Unlock series, where basically we're just like exploring the full spectrum of AI. My goal for this channel, I'm not trying to create traditional coding videos. There are plenty of channels that do that, right? I want to document my process in learning AI because Personally, I believe that we kind of already have AGI, depending on how you define artificial general intelligence. Check out my podcast, AI Renaissance Podcast, where I talk more about that. I'm just here to harness it. I'm just here to understand how it actually works so that I can harness this powerful tool that humanity has. And I want to use this tool for good, not for creating another WALL-E movie scenario, right? No. I want us to be able to harness AI so that we can synthesize information that we can actually... Anyways, I already talked about this in the AI Renaissance podcast, but we want to understand AI. How can we understand AI? The traditional way it's explained to us is, okay, we got to learn linear algebra isolated, we got to learn statistics isolated, we got to learn computer science isolated, and then we can start talking about machine learning algorithms. Now, I don't think that's a very efficient way to learn AI. I already talked in my previous video how this is not efficient. We don't want to learn AI through these isolated fields because AI is a transdisciplinary area. We want to learn all areas and see how they all fit together, basically. So if you have zero programming knowledge, zero math knowledge, that's okay. This is my attempt of me explaining what I've learned, synthesizing what I've learned, and teaching you programming, Python programming, and mathematics while we're constructing and building AI as if we invented it ourselves. So if that kind of sounds interesting to you, then yeah, like just join. So previous video, so again, we're learning AI while we're learning Python, while we're learning math. So that's what we're doing. We're not doing one by one. No, I think that takes too long. It's inefficient. Anyways, previous video, we talked about while loops. Very, very important concept in Python, while loops. In the video before that, we talked about if-else statements. And the video before that, we talked about variables. So make sure to check out those videos in our playlist, AI Unlocked playlist. Anyways, so while loops is very important. We already talked about this example. Check out the previous video. Today, we're actually going to be going back to this concept we were talking about in our if-else statements video. So just to recap, AI has two parts, prediction and agency. If you create a system that can predict, that can approximate reality, and then take that information and make a decision from that approximation, you have AI. Because that's what human beings do. That's what regular intelligence does. We human beings approximate reality. For example, I can see this cup, and the light is going to bounce off this cup and enter into my retina. My brain is going to approximate reality from the, I guess you could say, from the electromagnetic waves, right? From the information provided from the electromagnetic waves. It's going to do an approximation. But it's just an approximation. It's not representing 100% how reality actually is. The reason for this is because our senses can fool us, right? Our senses can fool us sometimes. Sometimes, we experience illusions. So we're never really certain about what we're actually seeing in the exterior world. We could probably even be in the Matrix, for example. Who knows? No, I don't think we're in the Matrix. We're not in the Matrix. But anyways, we just approximate reality. And AI does the exact same thing. It does it in computer vision. It does it in speech recognition. It does it when it's like talking to you. It does it when it's predicting the future. It's always going to be approximating. Now, there are two types of programming, right? There's traditional programming, and then there's implicit programming. So traditional, explicit programming is deterministic. That means if I take a look at the code, I already know what the output is going to be, right? I already talked about this in my previous videos. If you already know what the code is, you already know what the output is going to be. This is how 99% of applications work. It's just a bunch of code that's deterministic. If you click on a video on YouTube, what's going to happen? It's going to render that video, assuming certain conditions are true, right? Assuming that you have a proper internet connection, assuming that YouTube server hasn't crashed, right? Assuming a whole bunch of scenarios. As long as these scenarios are true, as long as these conditions are true, this is going to be the output. So if I were to look at the code, I can automatically determine what the output is going to be. When it comes to AI, there is no determinism. We cannot do determinism. We cannot rely on determinism. Why? Because reality is messy. Reality is super, super messy. I would have to create a whole bunch of if-else statements in order for me to, actually, there's always going to be something that I'm not taking into account. Very inefficient. So we have to do something that is opposite to randomness. Sorry, opposite to determinism. And the thing that is opposite to determinism is randomness, right? Spoiler alert. So, but we don't want the AI to just be random, because it's not going to be useful. We want to find a way to control the randomness, right? We want to control the randomness. We want to have structured randomness. Structured randomness. So in my previous video, we talked about while loops, and today I'm going to explain why while loops was important. So let me just switch these cells. Previous video, we talked about while loops. This is another scenario where we have let's suppose that we have a bot where the battery is at 5% or point, and eventually this loop allows the bot to repeat these set of statements until battery is equal to 0. So then it exits out of the loop, and then it prints out this statement, which is what happened here. Check out my previous video on that. Today we're going to kind of like simulate something similar using a while loop, but we're going to use the nature of randomness. We're going to try to, by the way, the field that studies structured randomness is statistics. This is why statistics is important. For those who probably didn't know why you're studying statistics in the first place. If you're in an AI curriculum, for example, they're teaching you statistics, and you're like, okay, but why do I need to know statistics to learn machine learning, right? They don't teach you that because you're learning it isolated. I'm here teaching you why you actually need statistics in the first place. Hopefully this actually makes sense to you. So, structured random approach. That is probably the more efficient way. But how does that even look like, right? Well, what I'm going to do here is I'm going to import a library. What is a library in Python? A library in Python, so imagine like a library in Python is just like you referencing another code that some other developers built, right? And without you having to code it again, if that makes sense. Like if I were to, this code right here that I have right here, I can create this into a library that you guys can reference so that you guys don't have to like recode it again, if that makes sense. So we'll talk more about that another time, but there are a bunch of libraries in Python that allows me to do stuff that I don't necessarily have to, that it allows me to reuse code, if that makes sense. So I'm importing a library, a very specific functionality in order to do the things that I'm doing today. So what I'm importing is a library called random. So I'm importing that library, but I'm also going to be importing another library called time. This is how you import libraries. Very easy. You just type in import and the name of the library. There are a bunch of libraries in Python that you can research on Google. Just explore all the libraries that there are. There are a bunch of them. This is why I don't tell people to like, hey, you have to memorize everything. No, that's not how you learn programming. You don't learn programming by memorizing, you learn programming by building. With that being said, these are important libraries that we're going to be using today. This is one way to import them. If you're importing multiple libraries, I could just type in one import statement and then type in a comma. Same thing. So I'm importing the random library, comma, and I'm importing the time library. So this is one way to import it. This is the other way. Same thing. So I'm just going to import it like this. So right here, I'm importing the random library and the time library. Great, I imported it. Now what's going to happen? So this is the code. So okay, I'm going to use this library. This is how I use it, because that's what the library is called. But now what I'm going to do, this library has a whole bunch of methods, a whole bunch of tools, let's say. Our library is a toolbox, right? So if you're building a house, you don't want to have to like reinvent the hammer. That's not like efficient. You want to buy a hammer, right? Someone already made the hammer for you, so you want to go and get the hammer for yourself, right? You want to like reference a toolbox, right? So this is the toolbox called random, and in this toolbox there are a whole bunch of methods. The method that we're going to be using from this toolbox is called randint. So this is a toolbox. Sorry, this is a tool within this toolbox, if that makes sense. Now, how do we actually call this tool? All we have to do is call first the toolbox, because that's where this tool is going to be located. So we first call it, and then we type in a dot, and then we type in the name of the tool that we want to retrieve from this toolbox. So imagine having like a bag or a toolbox, and there's a whole bunch of tools in that toolbox. When we type in this statement, what we're doing is we're taking that bag called random, and we're getting the tool called randint, if that makes sense. That is what this statement is doing, essentially. In order to understand the mechanics behind this, you have to understand classes, object-oriented programming, methods, You could probably watch that in separate videos. I'll create a separate video on that another time. But right now, that's like the essence of it. So this tool is going to be very useful. Now, this tool, so let's just explore this tool isolated first. So this tool called randint, sorry, I missed something, randint, yes, that's what it's called. If you watched my first video on Python, I briefly explained the concept of a function. Now, a function is just a machine that takes in something as an input, and then it's going to output something else, if that makes sense. So the input, so these parentheses right here, or brackets, whatever you want to call them, imagine it as like, so you see this cup right here? So this entire cup is my function. I can put something inside this cup right here, and it's going to output something else, if that makes sense. Or like, if I have this water bottle over here, I can put something in here, and if I poke a hole, it's going to output something else, right? If that makes sense. Or think of it like an oven. If I take all the ingredients, right, to make a cake, we got eggs, we got the bake or whatever, and you mix them together and then you put it in the oven is now going to output a cake, a cooked cake, if that makes sense, a baked cake actually. Whatever, I'm not a cook, as you can tell. So that's a function. So I'm going to be putting something inside the function, and the function is going to print something out. So that's actually how the print function works, by the way. I'm putting something in here, and when I execute this function, it spits something out. If I were to just do this, well, because I'm in Jupyter Notebook, it automatically uses the print function. That's why I'm still seeing this guy over here. But the print function spits out the result or the value into the console, if that makes sense. So that's a function. This right here, in a way, is actually a function, or it's a method. What's the difference between a method and a function? Well, it's just a tool that's defined in a toolbox. That's all a method is. But a method is really just a function. So randint is another function. And what are the parameters of the function? In other words, what can I actually put into this function? What is it actually going to spit out? Well, the thing that I can put in is, for example, 0, 100. What am I doing here? Well, let me just show you. If I were to, just type that in for now. I'll explain. Type that in and then press Shift-Enter, right? In other words, run the code block. Right here, I'm getting an error. What is the error? Randint is not defined. Python is like, okay, what do you mean randint? You didn't define randint. Turns out that randint is already defined in the toolbox or in the library called random. So I need to actually take the tool from the toolbox called random. So I actually have to type in random here first. Dot. Now Python is like, oh, you mean that kind of randint. I thought you were defining your own randint. That's what Python is thinking. I thought you were defining your own randint. But it turns out you're already using another tool called randint that's within the toolbox called random that you already imported up here, by the way. So now if I run this again, it spits out 43. Now what is this? Why is this important? Let me just get rid of the noise. So recap, we imported the library called random. We'll talk about this library later. We imported random, and then we're using the tool called randint, and we passed these parameters, and we got 43. What I'm doing here is randint, by the way, just means random integer. An integer is just a number, a whole number. So 5.5 is not an integer because that's not a whole number. That's a decimal, right? So it's what you call a float data type. Sorry about that. That was my phone. It's what you call a float data type. So this is an integer because it's an integer. It's a whole number. We'll talk about basic math later, but just to keep moving on, there's plenty of videos that explain what a decimal is or what a fraction is. In order to understand what a decimal is, you have to understand what a fraction is, and so forth. Converting between a fraction and a decimal. Khan Academy has a great course on that. We'll briefly discuss it later down the line, but in order for this video to not go super long, because it's already kind of long, we'll leave it at that right now. Right now, an integer is just no decimals, right? It's just any number that has no decimals in it, right? No fractions in it. If you do have a background in basic mathematics, then you probably understand what I'm saying. So this function is going to return any random integer, but it's not just going to return any random integer. It's going to return any random integer between 0 and 100. That's what these parameters represent. But here's the thing. If I were to run this again, it's not going to print out 43 anymore. It's going to print out 39. If I were to run it again, it's going to print out 91. If I were to run it again, it's going to print out 21. So this is what you call a non-deterministic program. This is non-determinism. This is what you call randomness. Of course, what you need to understand is that this is actually known as pseudo-randomness. What do I mean by this? It seems random, but it actually, behind the scenes, the randint function or method is actually implementing some mathematical algorithms. So it's actually not really random. The computer already knows what it's going to output. If I were to hypothetically understand the algorithm that it's using, I would automatically know what the next number is going to be. But it seems random, statistically speaking. True randomness is actually found in nature, specifically in a field known as quantum mechanics. Quantum mechanics, or provides us real randomness, but I'm not going to dive into that. Right now, we can treat this as if it was real randomness, right? Right now, let's just treat it as real randomness, just to illustrate a point. I don't want to dive deep into the nature of randomness. That's probably something I'll talk about in my AI Renaissance podcast, by the way, that you can check out on my channel. But right now, let's just treat this as actual randomness, even though it's not real randomness, if that makes sense. But there is real randomness in nature. But I'm not going to talk about that today. Let's suppose that this is real randomness. So no matter what I do, I'm not going to be able to predict the result, right? I can run this a bunch of times. I'm not going to be able to predict the result. This is what I want. This is what we need if we're going to create an AI that doesn't actually have to exhaust all possible scenarios. Great, we're getting to something, right? Now that you understand how this works, and this is actually very, very useful because it provides us structured randomness, which is what we want. We'll create a statistics course later down the line, but this is the concept that we need right now. Okay, let's suppose that we want to create an AI that can maybe detects that it's like if it's too dark in the environment right now, then it's going to turn the lights on. If it's just bright enough, for example, then it's going to turn the lights off. Of course, we need a threshold because it's like, okay, we need to find a way, number one, to measure brightness, right? And we need to implement a threshold. What do I mean by a threshold? So at which point is the AI going to decide? It needs a decision boundary. That's a very important concept in AI, a decision boundary, which once we dive into classification algorithms, that's going to be a very important concept in order for the AI to actually decide what it's going to do. And this applies for anything. It applies for even agentic AI agents that you hear online all the time about how they make decisions and do tasks and all these things. This has already existed. When we have classification algorithms that can classify whether an image is a dog or if it's a cat, right there it's making a decision. It's making an approximation, and then from that approximation it makes a decision. What does it decide? It decides if a thing is a dog or a cat, right? That's a decision. And it has a specific decision boundary, where if it meets a specific threshold, or if it surpasses that threshold, it's going to classify it as a cat. Or if it doesn't go above that threshold, it's going to classify as a dog, or something like that, right? It's more complicated than that, but that's the essence of it. So we need some kind of decision boundary. So we could say that the brightness, let's suppose that our brightness is going to be from 0 all the way to 100, right? And we're going to say that decision boundary, I can't talk right now. The decision boundary, let's suppose that the brightness of the room, it's going to be 30, for example. Let's say that that's the decision boundary. So if the brightness level is, let's say, less than 30, I did not mean to do that. If it's less than 30, then we are going to say that it's too dark, let's turn on the lights, right? That's the brightness. Too dark, let's turn on the lights. Otherwise, right, else, we are going to, so otherwise, it's bright enough, let's off the lights. It's bright enough, let's actually turn off the lights, right? So what we can do here, so we can put an if statement, right, where we talked about that. Don't forget your indentation. This is the scope. All right, so our decision boundary is 30. If it's less than that, then the model is going to execute this code. If it's anything that is not less than 30, that is if it's greater than 30, then it's going to execute this code. So let's suppose that our brightness level right now is 33. Yay, it's bright enough. Turn on the lights. Let's suppose it's 29. Too dark. Turn on the lights. Right? Simple. Now what does this have to do with this guy up here, with structured randomness? Well, if you already understood what a while loop does, which I talked about in my previous video, so I could say, for example, it can be any condition. While the AI is, let's say that, or our AI detector, let's say that 1 represents on, right? While AI detector is on, right? Let's say that 1 represents on and 0 represents off, right? While AI detector is 1, we can say, for example, that the brightness, we're going to not decide. We are not going to decide what the brightness is. Let's say that it's going to be something random, like randint, 0 to 100. So the brightness is it can be anything from 0 to 100. And we're not going to decide what that brightness level is. We're just going to let our environment decide what it is, because the environment, reality is random. Reality, there's a whole bunch of things that can happen in reality, right? Our AI just needs to learn how to detect reality, receive the data from reality, and make a decision based on a condition or some kind of decision boundary. So right now, our reality right now is that the brightness level can be anything between 0 and 100 that we're not defining, that we cannot predict. This is something that we cannot predict. Very important. This is implicit programming. This is something that we cannot predict. So our brightness is going to be, I don't know what it's going to be. It's going to be, all I know is that it's going to be between 0 and 100, right? That I know. So it's not going to be completely random, but it's not going to be deterministic. It's going to be controlled randomness or structured randomness. Because I do know it's going to be between 0 and 100. I definitely know it's not going to be 1,000. I definitely know it's not going to be negative 100. I know it's going to be between 0 and 100. So that's structured randomness. But I just don't know what that value is going to be. If it's going to be 3, if it's going to be 23, if it's going to be 79, I don't know that. So all I know is that my brightness is going to be between 0 and 100, and I'm not going to be the one that determines that. The AI is just going to react to the environment. This is our environment, and it's going to react to it. So our detector, we're going to turn on our detector. Our detector, 1 represents it's on, 0 represents it's off, right? We're going to turn on our detector. While AI detector is 1, in other words, while the AI detector is on, let's define our brightness. So here we're just initializing the environment, right? So while the detector is on, it's going to read this line. It's going to detect the environment. It's going to read brightness. And what is it going to do now? It's going to be like, okay, so let's actually like read this. So if brightness, so we have to define it within the scope of the while loop, right? It's going to repeat this as long as this is true. So let me just code things out and then I'll explain. So if the brightness is less than 30, it's going to print too dark, turn on the lights, right? Okay. If, or otherwise, if anything else is true, that is, if it's greater than 30, this is going to happen. So how the heck would this actually look like in real time? Oh yeah, we forgot to import it. Okay, don't forget to import it. Let me just clear out the noise. So we can run this code block to import the random library, and then we can run this guy over here. Oh, yeah, I misspelled it, randint. All right, that should work. And yeah, this is going to crash. This is going to crash because it's an infinite loop. So let me just pause this for now. Don't crash. There we go. We want to slow this down. So otherwise it's going to like just keep crashing. So let's actually slow this down using time.sleep 1. What does this mean? I'm borrowing from the time library and I'm waiting 1 second before I print the next line. So it could, just slow down. So let's do that. Hopefully I'm defining things correctly here. I keep getting mixed up with the while loop for some reason. So while AI detector is on, we're going to define our brightness variable. The AI is just going to react to that environment. It's going to read what the value of brightness is. It's going to check what that value, if it's going to check if the value is less than 30. That's our decision boundary, 30, right? If it's less than 30, it's going to print this guy out. If it's anything other than less than 30, in other words, if it's above 30, it's going to print this guy out. So it's going to print these lines. And let's see. So let's run this. All right, that's your little AI program. So sleep right now. This is just so the program is not going to execute super fast. This is just going to add like a little delay, a 1 second delay. And as you can see, This is your little AI detector, if that makes sense. It's reacting to the environment. So if I hypothetically connected this program to some kind of device in my room right now that actually detects whether if the brightness is somewhere between 0 and 100, it's going to react to that, if that makes sense. Okay, I just need to check something. All right. So this program is just going to continue. Again, I recommend you put in time.sleep. Again, we're using the time library, and we're using the method sleep, and we're delaying it by 1 second. So what that means is that it's going to print either of this statement, depending on what the condition is, and it's going to wait 1 second before it repeats the loop again, because we don't want it to just, crash, basically. So that's all time.sleep is doing. And here it is. That's all it's doing. It's reacting. This is an autonomous agent. No, it's not. It's not an autonomous agent, but it's just reacting to the environment. Essentially, this is very similar to how an AI agent works, a real AI agent. You hear like all over the place, AI agents, agentic AI. Nobody really understands what agentic AI truly is. A lot of these AI agents, they're not AI agents, they're just AI workflows. It's just following some kind of workflow, if that makes sense. True AI agents are autonomous, so they have a specific environment and they just react to that environment. This is something similar to this is just a very, very basic program. This is not like true AI, but it definitely touches into the concept of AI and the importance of structured randomness. Again, I'm gonna bring this home later, like as we progress, because this idea of structured randomness is very important. Right here, it's just reacting to the environment. Yeah. All right, so that's it for this video. I hope you guys enjoyed. Again, this is part of our AI Unlocked series where we go from 0 all the way to 100, where we basically learn how AI works as if we were inventing AI ourselves with zero background, zero programming background, zero math background. We're trying to dive deep into the concepts. We're imagining like, okay, if we had to start from zero, if society didn't invent AI, if we didn't have ChatGPT right now or none of these things, how would you invent AI, right? From zero programming, with zero programming experience, just with the basics of Python, how can we slowly build ourselves to actually building an entire neural network from scratch or building an entire transformer from scratch? The algorithm that powers ChatGPT. How would we do that, hypothetically? That's what the series is about, by the way. If you enjoyed it, like it, share it, comment. If you want to see some stuff, some cool stuff or whatever, just comment. If you have some questions, comment. If you have some critiques, comment. If you have some suggestions, comment. If you know anybody who's also interested in this, share the video. And please subscribe, man. Like, if this is something that you enjoy, subscribe. Yeah, because this is something that we're doing weekly, on a weekly basis. I'm trying to, like, upload at least 2 to 3 videos each week. So this is something that we're going to be continuing for the rest of the year, and whoever knows how long this is going to take. So with that being said, thanks.